So today we're talking about probability. We'll get to odds eventually. So probability is simply how likely an event is to occur. There's a very simple formula that we use to determine probability. Okay? No.
You're on a totally different topic.
Yeah. So, in the numerator, we're going to put the number of ways to succeed. And in the denominator, we put the total possible number of outcomes. This will make a bit more sense when we do an example. So let's start with something easy. Let's say I put the words or the letters let's say I put each of these letters on an index card. And then I put the cards in a bag and I'm going to pick a card at random. Sure. There's no, I'm sorry. This really should be an equals. This is the formula. So, everybody understands the scenario. I'm going to write each of these letters on an index card. I'm going to mix them up, and I'm going to choose the card at random. So, I want to talk about the probability of me selecting the letter M. Okay? So, one way to write that, instead of writing out the words probability of selecting an M, we can write it like this. So, when we put a P and then in parentheses, P just stands for probability. And then this is what I want to happen, selecting an M. So if I'm going to pick from all these cards, how many M's are there? Two. So there's two ways for me to get what I want. If I'm trying to pick an M, there's two ways that I could succeed. I could pick this one or I could pick that one. So that would be my numerator. And then the denominator would be all the cards that I could have picked. How many cards am I picking out of? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total cards.
This would be 1 in 6.5 chance.
Yeah, so probability, guys, you can express it two different ways. You could express it as a fraction, which you should always reduce. I can't reduce 2 over 11, so I can leave it. Or you can change it into a percent. You all know how to change fractions into percents. What would I do to figure out the percent for 2/11ths? Yeah, 2 divided by 11, I get 0.181818181818. So what's that as a percent? That's my decimal. 18.18 repeating percent.
Or rounded to 18%.
Right. So if we round to the nearest whole number, it would be about 18%.
Do you have to round to the percent?
It depends.
On the sheet?
Oh.
Wait, so we could just leave it in like as 2/11?
You can leave it as a fraction or you can change it to a percent.
It's a low percentage.
It is a low percentage. So you're probably not going to select an M, but you could. What is the probability that I select an I?
1.
Guys, the answer's not 1, it's
1 over 11.
1 over 11. Big difference. So 1 over 11, if I was going to change that into a percent, would be approximately, well, if 2 11ths is 18, 1 11th would probably be about 9%. What is the probability that I select a vowel? First of all, you need to know what a vowel is.
Four.
A-E-I-O-U.
E. Oh, 4.
So that's not the probability, that's the number of vowels.
Oh.
4 out of 11 is correct. So if 2 out of 11 is 18, 4 out of 11 is probably 36. What is the probability that I will select a letter? Right. And I got two different answers. Joe W. said 11 over 11, and I think Aiden said 100%. So what is 11 out of 11, really? Yeah, it reduces to be 1, which is 100%. So if something has a probability of 1, it's absolutely going to happen. So if you're going to pick one of these cards, you're going to pick a letter. That's absolutely going to happen. It would have a probability of 1. What is the probability of me selecting, I don't know, a B? 0 out of 11, which would be what percent? 0%. So the highest a probability could be is 1, 100%. The lowest it could be is 0, meaning it's never going to happen. If I really take the letters of the words of mathematics and I pick one of them, there is no B, so it would never happen. Easy enough? Have you guys done this before?
Yes, ma'am.
Oh, some of you have, some of you haven't. So let's make it a little bit more interesting. How about the probability, let's see if I can put this all at once. Probability of not selecting an A. Don't say it out loud. Everybody get your own answer. Write it down as a fraction, and then change it to a percent if you like. Does everybody have an answer? Ben, what is it?
81%.
What's the fraction? Can you back up to
9
that?
over 11.
Right. There's 9. So let's say we're playing a game and I'm going to win as long as I don't pick an A. That's all I have to do. Just don't pick an A. Well, there's 9 ways for me to not pick an A. I can pick everything else. Skip over the A's. There's still 11 total cards. So Ben's right. If 9 over 11, that's going to be about 81%.
Not exactly that.
Yeah, so we should put squiggles.
What does that mean?
When you put the wiggles, that means you rounded.
The wiggles like some kind of British or European show or something.
I have no idea.
Oh, the Wiggles.
Australian.
The Australian.
Oh, the Wiggles the band. I know all about the Wiggles the band. I could recite their dance party CD by heart.
I never got to watch it when I was little, but
Wait, what?
There's an Australian group called the Wiggles. The new Wiggles,
Is it like Yo Gabba Gabba?
kind of. 2 of them got married, but then they got divorced like 3 months later. I know. I was like, no! It was a fairy tale marriage. Okay. There is, right?
You spelled it right.
All right, guys. So, let's take a look at this sheet. So you roll a single die numbered 1 through 6. What's the probability of rolling a 3? Well, a single die. Miss Brady, could you hand me one of those big ones up there?
Oh, yes.
We finally get to. Yes. So here's a single die. Dice is plural. So if you're talking about 1, the correct word is die, D-I-E. 2 is dice or more.
Can you throw it?
Yeah, can you throw it to him?
I sure, well, I can roll it.
Can you?
Throw that cold.
Should I throw it
Throw
across
that
the room?
cold with this.
Well, guys, what is the probability of me rolling a 3?
1 over 6.
1 out of 6. Right, there are 6 sides. So I have 6 equal opportunities to land on any one of them. So the probability of rolling a 3 would be a 1 out of 6. If you change that to a percent, what'd you get? Yes, if we're going to round that to the nearest whole, that's going to be a 17%.
What? Oh.
Yeah,
I swear you
maybe at the end.
What?
Yeah, I know.
Wait, we can do a probability of rolling a number, like, when, like, catch it.
Wait, just number 2. Yeah, we should.
We're not on number 2 yet.
I won't talk ever again.
Let's now jump. Oh, wow. Are these all? Okay. Try number 7. 7, if you look back up at number 6, they're doing the same thing that we did with mathematics, just with the word Mississippi.
Wait, are we gonna learn about odds today?
Yep. Okay, guys, so you're trying number 7. They're using the letters in the words Mississippi. We want to figure out the probability you choose an S. Everybody, please write down your answer to number 7.
Wait, what are we doing? Number 7?
Yes.
We're doing 7 or 6?
7. But you're using Mississippi from number
This
6.
is a lot of odds.
Yeah.
They're all odds. All the rest of them are odds.
Okay. Well.
We'll do odds.
36.
Hi. Yeah.
Keep on writing one line.
Okay, we got our answer? Tell me what you get. What is it? Oh! Oh, it's John's bag.
Is it a Santa suit?
4 out of how many? 11.
Oh, I got 3 out. Wait, I miscounted, but I cannot.
Yeah, you got 4 S's. So 4 out of 11 is about 36%.
Now it says your system seems to have trouble starting. Dell support
Oh,
is
Jesus.
scanning your hardware for a possible core. Call.
Great.
Have you ever had that before?
Ah,
Yes, I did. He said, oh, that's nothing to worry about. Okay. So, one other thing that I want to go over before we move on to odds is something called sample space. Let's say I was going to, I don't know, roll the dice. In your die, roll a die. The sample space is literally just where you list all the possible outcomes. So I could either roll a 1, 2, 3, 4, 5, or 6. Okay? Let's change gears a little bit. So this is sample space for rolling a die. What if I were to flip a coin? Let's say we wanted to do the sample space for flipping a coin. What could it come out as? Heads or tails? What if I was going to flip 2 coins? Flip 2 coins. Go ahead, write it. Write your sample space for flipping 2 coins. All the possible outcomes if I flip 2 coins.
Heads, tails, heads.
Well, everybody write it. How about 3 coins? Oops, I didn't mean to do that. I didn't mean that either. I didn't mean that either. Two heads, 2 tails. Okay, how many did you get for 3 coins?
I knew what it was saying. So first, 4.
Did everybody get the same that I got?
No.
So let's assume I'm going to flip 3 coins. What is the probability that they will all land on tails? 1 out of 8. This is all the possibilities. There's only one way that they could all land.
Factorial for this?
No, but I would use exponents. So I have 2 possible outcomes for each coin. So this one, I'm going to flip it once. So I have 2 to the first. This one, I'm going to flip 2 coins. So I have 2 squared. This one, I'm flipping 3 coins. So that'd be 2 to the third. So if I flip 4 coins, it'd be 2 to the fourth. I guess you could use factorial. Well, no, it wouldn't be. You could use the slots, though.
Find out all the outcomes.
Well, I just list them all. But that's how many you'll have by doing 2 to whatever power. So, because each coin has 2 options, right? So if I'm only going to flip 1 coin, there's only 2 options. But if I flip 2 coins, they each have 2. So 2 choices for the first, 2 choices for the second. If I have 3 coins, 2 choices, 2 choices, 2 choices. So 4 coins would be 2 times 2 times 2 times 2. Or times 2 is 16. So if you flip 4 coins, there's 16 possible outcomes. Anyway, so I asked you for the if I'm going to flip 3 coins, probability all tails. You told me 1 out of 8. That's correct. What's the probability I will get at least 2 tails? At least 2 tails.
Is it 5?
I don't think so. That's an H.
Is it 4 out of 8?
Yeah. So, finally, we have a fraction that can be reduced. You shouldn't leave it as 4 over 8. You should turn into 1/2. Or 50%. Super fast. Okay. The last thing that I want to talk about before we move on to odds, some of you are not that familiar with decks of cards, as I would like you to be. So, we're going to talk about cards. Yes, there are in a deck of cards. Deck of cards.
4 odds.
Right, there's 52 total cards, and you have 4 what we call suits. There's hearts, diamonds, clubs, Look at my expert drawings,
That's fantastic.
right?
Yeah.
I couldn't tell what that was at first, but now I can.
These first two, the hearts and diamonds, are red.
I didn't even play cards with my dad, and I obviously know.
These two are black. I'm not going to fill them in because it's going to take me forever. Now, in each suit, ladies, gentlemen, there's 13 cards in each. So there's 13 hearts, 13 diamonds, 13 clubs, 13 spades. And they go from the number, they start at 2, 3, 4, 5, 6, 7, 8, 9, 10 is the last number card. Then you go Jack, Queen, King, Ace. And that's the same for all of these. Okay?
Ace is a high card or low card when you go to
That's a spade.
How many cards are there total?
52. Always
No,
52.
In a suit.
13. 13 in each one.
What about the aces?
They're there. Down there. Jack, Queen, King, Ace.
She's got
Oh, sorry. There they all are. So, a lot of times when you are doing probability and odds, we talk about decks of cards. But if you don't know how many total cards there are, how many of each one there is, it could get a little messy. But now you all know, right? Okay, perfect. So if I asked you, what's the probability of selecting a 7? Any 7 you want out of a deck of cards. 4 out of 52. So probability of selecting a 7, 4 out of 52. What is the probability of...
I'm behind.
Oh, sorry. You don't have to write these all down if you don't want to.
You should reduce that 4 out of 50.
Oh, yes, thank you.
113?
1/13. What is the probability of selecting an even card? Even number card.
I'm behind.
Except you also have to
Okay.
count, like the gestures and stuff, because they technically do have numbers in certain playing this card.
They don't here. So just the numbered cards, even ones. Yep.
5 out of 13 or so. Wait, the even cards?
It's 20 out of 59.
Oh, yeah, but you add all of them up. Or do you mean like all the same suits too? Or just all of them?
Any even number card. So are we all in agreement that there's 20 in total?
Yes.
20 out of 52, which would reduce to,
Um,
I think it's 5/13. What is the probability of selecting the Queen of Hearts? 1 out of 52. There's only one of them, right? What is the probability of selecting, let's do a number less than 5. Aces are the high card here, so aces they're too high. Don't count the aces. So what did I say, less than 5?
The answer's 12.
Less than 5. Everybody's got an answer? What is it? And what does that reduce to? Okay, let's make things a little bit more interesting. What's the probability of selecting a black ace. Yeah, look at you guys go. How many black aces are there? 2. The club and the spade. So it'd be 2 out of 52, which reduces to be 1 out of 26. And we'll do one more before the odds. What's the probability you select the diamond? Yeah. Or
Reduce. Reduce, reduce.
Oh, we're supposed to say it?
yeah.
Oh.
I want the reduced fraction.
Why didn't you say it?
You're making it harder than it is. Diamonds make up what fraction of the whole thing? 1/4. Yes, 1/4. What's the probability of selecting any black card? Half, right? Aren't half of them black and half are red? So half. Okay. Ready to talk about odds? Okay. Odds are very similar to probability. It's just that we change the bottom number. It's not out of the total possible. Does anybody know what it's out of instead? Odds. So the formula for odds, let me zoom in here. This, you still are going to have the number of ways to succeed on top. On the bottom, though, it's number of ways to fail. So it's not the total, it's number of ways to fail. So, let's go back to a simple, let's say we're going to roll the dice, okay? If I want to talk about the odds of rolling a 3, for example. So, the odds of rolling a 3. How many ways are there for me to get what I want? If I roll one die, how many 3s are there? Just one. So there's one way for me to succeed. How many ways are there for me to fail?
8. Wait, how many sides are there? 6.
So there's
5.
5. If I land on the 3, I win. But if I land on any one of the other sides and there's 5 left, those are my odds of rolling a 3. Very often we express odds as a ratio instead of as a fraction. So, ladies, gentlemen, you'll often see this written as 1 to 5, like that instead. It's the same meaning as the fraction.
So no percentage.
No, we don't usually do a percent for
It's 20%
odds, right?
wide.
No.
Yeah, so usually you just see it written with the colon. You can still reduce odds, so you should, because this is really just a fraction.
So 1 to 5 chance.
Well, there's one way to win compared to 5 ways to lose. So the odds are against you.
So there's a 20% chance of winning.
No,
No.
because it'd be 1 out of 6. Because you really don't do percentage for odds, right? Yeah, don't change odds to percents. It's just one way to win and 5 ways to
Is
lose.
there a way to convert it to probability?
Yes. You have to add together the wins and the losses to get your bottom. So it'll be 1 over 6.
Because this is always wins, ways to win, and this is ways to lose. Probability is ways to win over total. So the total outcomes are 6, but odds, you always want to compare wins to losses.
So it's a rare chance of winning.
If you were trying to roll a 3, sure. You have a greater opportunity to lose than you do to win. There's 5 ways for you to lose, only 1 way for you to win. However, let's pretend we're playing a game, and I'm going to, let's say I'm going to win this game as long as I roll an even number. That's all I have to do. So if I want the odds of rolling an even, so how many even numbers do I have on a single die? 3. There's 3 ways for me to win. How many ways for me to lose? 3. So the odds of rolling an even are 3 to 3 or 1 to 1 if you reduce it. So you're just as equally likely to win as you are to lose.
You have to reduce.
You do with odds, right? Yeah.
Reduce, but then don't just change it to 1. Don't just change it like it's a fraction.
Right.
1 over 1 is 1, because you want to see the two different things. You want to see the number of ways to succeed to the number of ways to fail. So there's got to be, it's a ratio. You've got to see both parts.
Let's go back to our cards. What are the odds? Let's see if I can get all of this on here. I don't need that. There's all that. Okay. What are the odds of selecting a king?
Any king?
Any king, any suit. So how many ways are there for you to win? 4. Against how many ways to lose now? 48. So let's reduce that. That would be 1, 2, 12. Yep. The odds are not in your favor. How about the odds of selecting any number card? Selecting any number card. So you just need a card with a number on it. So not a jack, queen, king, or ace. Any of the other ones are fine. How many are there? 26? 36?
Wait, then you number card? 40.
9 times 4, 36. And how many non-number cards are there? 16. So if I reduce this, I think it's 9 to 4.
Yep.
Here, the odds are in your favor. There's 9 ways for you to win and only 4 ways for you to lose. So if you're playing some game and you're going to win, as long as you select a number card, you're probably going to win. It's not a guarantee, but the odds are pretty good in your favor. Does this make sense, the difference between odds and, well, odds and probability, I meant. Okay, let's try one more with odds and the cards. How about, what are the odds you're going to select a heart?
13.
Out of, to what? So, Alexa says there's 13 hearts. She's right. But how many non-hearts are there?
39.
39? So if we reduce that, that would be? One to 3. Just just remember that each suit is 1/4 the whole deck, right? So there's one way for you to win and 3 to lose. Yeah, so 1, 2, 3. Okay. How do we feel? Okay-ish?
I feel great.
Let's look back at this worksheet now and see. Huh? What do you think? Because I'm a nice teacher, you're going to have homework on it. Yes, they would, because they want to make sure that you understand the material on your own. It's easy when I do it. It's you seeing for yourself. Do you understand what I talked about all class? All right, let's try number 2 together. It says, what are the odds of rolling a 3? So we're back to just a number, like rolling a die. So how many number 3s are there on this? 1. How many ways are there for me to? 5, because it's ways to win to ways to lose. There's 6 in total, but that's a way for me to win. So that's a win, but these 5 are losers. Yeah. So 1 way to win, 5 ways to lose. Yep. Goes super fast. Try 3. So we have a jar, 12 pieces of licorice, 7 mints, 16 pieces of toffee. What are the odds of selecting a piece of toffee if a piece is chosen at random? Odds. So you always have to make sure you're reading the question carefully to see if they want odds or probability, because they're different. So they want odds. The odds of selecting a piece of toffee. So how many ways are there for me to succeed by picking a piece of toffee? 16. And then how many ways are there for me to lose? 19. Correct. Can you reduce this? Not this one. Let's look at 4. A number from 14 through 24 is drawn at random. What are the odds the number will be less than 22? So, for a problem like this, I think it's easier to write out the sample space. It's not that big. So I'm going to have the numbers 14 to 24. All right, I'm going to pick a number at random. What are the odds the number will be less than 22? So, Devin, how many ways are there for me to win?
7.
Sure? Yeah, so 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we wouldn't count 22 because 22 is not less than 22. I have 8 ways to win. How many ways to lose? 3. 22, 23, 24. Those are all losing.
But how do you convert it to probability?
Well, if you wanted to do probability, there's still 8 ways to win, but how many total outcomes were there?
11.
Which, don't you see something with these numbers in 11? If you add those two, that gets you the total.
Like 8 out of 11.
Right, so that would be probability.
So for the most part, we're not going to ask you to change back and forth between probability and odds.
Yeah.
That'd be a
Ask you one or the other.
That would be about a 73% chance of winning. Of getting a win.
And that makes sense. If the odds, if the first number is bigger than the second number, that means the odds are ever in your favor, Hunger Games. So you're probably going to win if this number is bigger than that one.
73% chance of winning. About. Not exactly.
5. What are the odds of drawing a spade?
13,
2.
52,
4.
That's probability. You want odds. 39, which reduces to
1 to 3.
1 to 3.
So you're gonna lose most likely.
I think they can finish these, Mrs. Sage.
I think so too. So, hopefully this recorded.